So APM stands for Analytics and Predictive Modeling, and this is a video on the emerging role of generative AI. We're in a big data revolution. Big data allows us to create sophisticated, highly complex, very complicated predictive models. Joint probability distributions over millions of random variables and billions or trillions even of tunable parameters. With data that can be anything, documents, images, videos, graphs, you name it. And careful sampling of such probability distributions can actually produce documents, images, videos, graphs, and so on and so forth that are actually representative. They could have actually been in the data set themselves. This is generative AI. For example, one model in particular is all the rage these days, ChatGPT. ChatGPT is a large language model comprised of a generative model, samples a predictive model for the data that corresponds to a given set of labels. It's a pre-trained model. Parts of the model are frozen after initial training, so the rest of the model can be fine-tuned. And it's a transformer, a neural network architecture introduced in 2017 by Google Brain and Google Research. Now, this GPT architecture is used to implement a chatbot. So ChatGPT is remarkably versatile. For example, suppose we wanted to know what exactly does id est idealis mean. We could do a Google search, and that's not helpful. We could do another search engine. That's not real helpful. Or we could ask ChatGPT.
The Latin phrase id est idealis is already quite close to the intended meaning, which seems to be something like that is ideal or that is perfect. However, if you're looking for an alternative phrase with a similar meaning, you could consider id est perfectum, which translates to that is perfect.
That's really versatile, but it's not very good at math. For example, let's look at this high school algebra problem. It's relatively straightforward. You just do some grouping and then you can factor it. So ChatGPT, now this is 3.5. Let's ask it to factor this problem that we just factored.
The expression x cubed plus 2x plus 3 is a cubic polynomial. To factor it, we first need to check if it has any rational roots using the rational root theorem. The rational root theorem states that if a rational number p, q is a root of a polynomial with integer coefficients, then p is a factor of the constant term, 3 in this case, and q is a factor of the leading coefficient, 1 in this case. In this case, the possible rational roots are plus or minus 1 and plus or minus 3, since the factors of 3 are 1 and 3. However, by testing these values, we find that none of them are roots of the polynomial. Since there are no rational roots, the polynomial cannot be factored into linear factors with integer coefficients. This means that the polynomial x cubed plus 2x plus 3 is an irreducible cubic polynomial over the integers and cannot be factored further using simple algebraic methods.
Nonsense. We just factored it. But nonsense with a nice British accent. Now, ChatGPT 4 was a slight improvement. But most people say, well, if you're going to use ChatGPT for math, you probably want to add the Wolfram Alpha GPT plugin. We've been doing Wolfram Alpha since 2005. And the output from ChatGPT 4 is almost exactly the output from Wolfram Alpha if you use the plugin. So ChatGPT without the plugin is actually still pretty bad at math. Let's factor x to the fourth plus 4. So it's again a pretty straightforward problem, just a little bit of regrouping.
The expression x caret 4 plus 4 can be factored using both real and complex numbers. The factorization is as follows: x caret 4 plus 4 equals x squared plus 2, x caret 2 to 2. This is a difference of squares pattern, where we have used the formula a squared b squared equals a plus b, a, b, with a equals x squared and b equals 2. So, the expression x caret 4 plus 4 can be factored as x squared plus 2, x caret 2 to 2.
So there you see, it's just flat out wrong. That's just wrong. It's a common high school mistake. And huge amounts of ChatGPT training data is from an internet full of common high school mistakes. And the nonsense can be devious. It can even look like it's true. For example, let's factor x to the fourth plus 4 using ChatGPT 4.0. And notice that it gives us this result, and it does it in steps. Step 1, Step 2, Step 3. And there you can see that it gives us this final answer. But notice its final answer is not the same as the answer immediately above. So they can't both be true. And this step that it did is completely wrong. X plus the square root of 2 times x minus the square root of 2 is x squared minus 2, not x squared minus 2i. Let's look at another one. Let's factor x to the fourth plus 1. Here is the result. Notice that it gives us the correct output, but it has this sum of squares by using this identity, which is completely wrong. For example, if a is 1 and b is 2, a to the fourth plus b to the fourth is 17, which is prime, and the other side is 5 times 3, which is 15. And notice that it actually has in step 3 that a fourth degree polynomial is equal to a sixth degree polynomial. So it just gave us nonsense, and then probably sent the math to Wolfram Alpha to give us the final answer. In other words, as my wife said, ChatGPT peeks at Wolfram Alpha's exam paper to get its final answer. So in general, large language models have big problems. They produce incorrect results, which are often called hallucinations. They don't know their result is incorrect. They typically cannot correct the result when requested. AI also generates errant results for images and other types of models. So data science and AI are fantastic when they work. Casual users don't test them, they just want the wow. But it is possible to assess the quality of large language models and use them productively, even though they sometimes make mistakes. For example, aging a photo. This is very popular. Here's me in 1985, and here is me aged 40 years to, or approximately 40 years to 2024, and here is me today. Not close in my opinion. Here I am in 2015. Here I am aged 10 years. Well, that looks pretty good, doesn't it? Except it doesn't look anything like me. That is, large language models are fantastic when they work. And there is therefore a critical need for experts in large language models who can make them work. And today's world expects today's data scientists, which will be you by the end of this course, to be those experts. And so we're going to make you into those experts. We're going to begin the development of your expertise with large language models by looking at the application known as code generation. You'll still need to learn Python, and you'll also learn how to use large language models to generate Python code. So our initial focus, large language models as coding assistants. For example, how would I define a function in Python that returns the factorial of a positive integer argument? Now, a function is an input-output process of the form y equals f of x, which returns one and only one y for each argument x in the domain of f. So here is a picture of a function, a graph, but here's what a function actually is. It's a model or an algorithm. The key term here is that there's one and only one y for each x, one and only one return for each argument. And we're going to have to rely on modern definitions because the AI models do. You can't use vague partial understandings of math concepts and get anything useful out of these large language models. So prompts to large language models should state the context you're working with and should ask a question explicitly and correctly with modern definitions in that context. Don't expect the code generated by a large language model to work. Usually it doesn't. So you must know Python, both so you can ask good questions and so you can work with the large language model to fix the generated code. For example, if you set up an account on Anaconda Cloud, then it looks something like this. You have to get an account, but it's free. And then you can go to this notebooks and you'll get something that looks like this once it's started up. And it will ask you if you want to use the assistant. This is actually ChatGPT specifically for Python applications. Confirm your age, click continue, and now you've got the Anaconda assistant, ChatGPT for Python in JupyterLab. So define a Python function that returns the factorial of a positive integer argument. Here's its response. Now I could copy this code, or I could click this little run arrow and run it in the notebook. And there it is. So let's see if it works. Let's take the factorial of 5. Well, I type that in, and then I can click the arrow there on the toolbar or do Shift Enter to execute this cell, and I get 120. But what about if I put in -1? Well, notice that we said positive integer in our prompt, and therefore it throws an error when you have a negative integer. But what about the factorial of 0.5? Well, then we get this weird looking sort of thing, a type error. And we just don't want to do anything that's at positive integers. So we can go to the Anaconda assistant again, and we can ask the question, or actually the statement, modify what you've done so that it also raises a value error if the argument is not an integer. And here we have, again, the code for our factorial function. And notice that it now will raise a value error if you don't have a positive integer, and a value error if you put in a negative number. That is, AI, not me, is going to be your coding assistant for Python and machine learning coding. I'll introduce Python in the first week, and I'll do many examples this semester. But I will not answer how-to questions. Those questions should be directed to an LLM. ChatGPT, Claude, GitHub Copilot. Well, that one costs money. It's really nice, but it costs money. The Anaconda Assistant, so on and so forth. I'll also provide guidance on how to ask good prompts and get good quality code. And I'll have much more to say about this in the next video when we examine the structure of this course.